There is a concept in meteorology that most people outside of this field have never heard of. And I want to explain it to you right now because understanding it is the only way to fully grasp the severity of what is bearing down on multiple regions of this planet over the coming days. The concept is called a storm train. Not a single storm, not an isolated system that moves through, drops its rain or snow, and allows communities to recover before the next event arrives. A storm train is something fundamentally different and fundamentally more dangerous. It is a succession of back-to-back atmospheric systems locked into the same track, fueled by the same anomalous jet stream pattern, delivering blow after blow to the same geographic areas with no meaningful recovery period in between. The damage from the first storm has not been cleaned up when the second arrives. The rivers swollen by the second system have not crested and receded when the third one dumps another 8 inches of rain on the same watershed. The power crews working to restore electricity after the first event are still in the field when the second wind event knocks down the same infrastructure again. Storm trains do not just produce weather, they produce cumulative catastrophe. And right now, the global atmospheric pattern has assembled itself into one of the most textbook, most dangerous, most historically rare storm train configurations I have ever analyzed in my career as a meteorologist. What is coming is not one event you need to prepare for. It is a sequence, and the sequence is already in motion. Let me give you the atmospheric architecture behind what is happening, because the science is genuinely remarkable, and I want you to understand why this is not hype. The engine driving this entire storm train is a large-scale pattern called a Rossby wave amplification event. Rossby waves are the massive undulations in the jet stream that circle the globe at upper levels of the atmosphere, and under normal circumstances, they propagate eastward in a relatively orderly fashion, steering individual storms along somewhat predictable tracks. What happens during a Rossby wave amplification event, which is what we are currently experiencing, is that those undulations grow in amplitude dramatically, meaning the troughs dive much deeper toward the equator, and the ridges build much higher toward the poles than normal. When this amplification reaches the degree we are currently observing, 2 things happen simultaneously that create storm train conditions. First, the energy available to individual storm systems increases dramatically because the temperature contrast between the deep, cold troughs and the elevated, warm ridges intensifies the baroclinicity, the atmospheric instability that powers cyclone development. Second, and more importantly for the storm train mechanism, the propagation speed of the wave pattern slows dramatically. The systems stop racing eastward and instead become quasi-stationary, meaning each new storm that develops gets steered along essentially the same track as the one before it. That is the storm train. Same track, same targets, no recovery time. And right now, that train has multiple cars on the track simultaneously, and it is heading for populated regions across 3 continents. The first system in this train, System 1, is already a fully mature and destructive event that is currently impacting portions of northwestern North America and the North Pacific. I want to describe this system in detail because it sets the baseline for everything that follows, and because the impacts from System 1 are going to still be unfolding when System 2 begins to arrive. System 1 developed rapidly over the Central Pacific 3 days ago, and in the 48 hours following its initial development, it underwent what meteorologists call explosive cyclogenesis, a deepening of central pressure exceeding 24 millibars in 24 hours, which is the formal threshold for what the meteorological community calls a weather bomb. System 1 exceeded that threshold by nearly 50%, dropping pressure at a rate not observed in this region since records of this quality have been kept. The fully mature low that is now moving on shore is carrying central pressure values in the 940 millibar range, and the wind field it is producing is catastrophic across the affected coastlines. Coastal communities across British Columbia, Washington State, Oregon, and Northern California are currently experiencing, or are about to experience, sustained winds of 60 to 75 miles per hour, with gusts exceeding 100 miles per hour across exposed headlands and elevated terrain. Storm surge along the coast is running 2 to 3 feet above astronomical tide levels, and where that surge is arriving simultaneously with high tide, inundation of low-lying coastal areas is occurring. Rainfall totals from System 1 are extraordinary, 12 to 18 inches in the coastal mountains over a 48-hour period. And that rainfall is cascading into river systems that were already running at elevated levels from prior precipitation earlier this season. Multiple rivers in the Cascade Range and Coast Range are currently in flood stage or approaching it, and the addition of another 10 to 15 inches of rain over the next 24 hours, as the back end of System 1 moves through, is going to push many of those rivers well above their banks. If you are in a flood-prone river corridor in the Pacific Northwest right now and you have not made preparations to evacuate if ordered to do so, please make those preparations immediately. Do not wait for the evacuation order to begin thinking about where you will go. Now I need to tell you about System 2. because System 2 is in some ways more dangerous than System 1, and it is going to begin arriving before System 1 has finished its assault on the same coastlines. While System 1 was developing over the Central Pacific, a second disturbance was simultaneously deepening along the same storm track roughly 1,800 miles behind it, and that second disturbance has now also undergone explosive cyclogenesis. As I speak to you right now, System 2 is a fully organized, rapidly deepening cyclone with a central pressure already below 950 millibars, and still falling. The models are in agreement that System 2 is going to reach the coast within 36 to 48 hours, and critically, the track it is going to follow is essentially identical to the track of System 1. Same landfall zone, same inland trajectory, same river basins that are already flooded from the first event. The meteorological expression for this scenario is a Pineapple Express double tap, and I want to be unambiguous about what that means for communities that are still cleaning up from System 1 when System 2 arrives. It means flooding that was serious becomes catastrophic. It means rivers that crested and receded even slightly simply rise again higher than before. It means infrastructure that was weakened by the first event fails completely under the second. It means evacuation routes that were open during System 1 may be compromised by the time System 2 makes that option necessary. Rainfall totals. From the combined impact of Systems 1 and 2 across the most heavily affected mountain ranges and river valleys in the Pacific Northwest are going to be staggering. When I add the accumulations from both systems together, I'm looking at storm total rainfall of 25 to 40 inches in the Coast Range and cascades over a 5 to 6 day period. To put that in historical context, the wettest month ever recorded at some of these locations received that much rain over 30 days. We are talking about receiving a month's worth of rain in a week, on top of ground that is already saturated and into rivers that are already running high. The flooding that is going to result from this combination is not going to be flash flooding in the traditional sense. It is going to be widespread, prolonged, slow-moving inundation that covers enormous geographic areas and that persists for days after the rain stops. That is a fundamentally different emergency response situation than a fast-moving flash flood, and I need every person in the affected river valleys to understand that difference. A fast flash flood gives you minutes to react. This style of flooding gives you hours, but only if you are paying attention and acting on the warnings before the water arrives, not after. While all of this is unfolding along the Pacific coast of North America, the same Rossby wave amplification driving that storm train is simultaneously generating a separate but atmospherically connected storm train across the North Atlantic. And the impacts on Western Europe from that Atlantic train are every bit as serious as what I have just described for North America. The ridge of high pressure that is building in response to the deep Pacific troughs has extended a ridge axis across the Arctic that is deflecting the Atlantic storm track in a configuration known to produce back-to-back explosive cyclones targeting the British Isles and the near continent. The first Atlantic system in this sequence, which I will call Atlantic System 1, is already delivering destructive winds across Ireland, Scotland, and northern England as I record this forecast. Gusts exceeding 120 kilometers per hour are occurring across Ireland's western coastlines. Significant structural damage has already been reported. The Irish Meteorological Service and the UK Met Office have both issued their highest level warnings for ongoing impacts. But Atlantic System 1 is not the story I want you focused on. Atlantic System 2 is already visible on satellite imagery and on every reliable numerical weather prediction model, and it is developing faster and to greater intensity than the first system did. The models are showing Atlantic System 2 reaching a central pressure below 940 millibars before it arrives at the European coastline, potentially matching or exceeding the deepest Atlantic cyclones on record for this time of year. The wind threat from this system across Ireland, the United Kingdom, France, the Benelux countries, and into northern Germany and Scandinavia is historic in its potential. I'm seeing forecast gusts in excess of 140 kilometers per hour for exposed western and northern coastlines, with inland gusts of 100 to 120 kilometers per hour across a much broader area. At those wind speeds, we are talking about widespread structural damage, mass tree falls across forested areas, extensive power outages affecting millions of people simultaneously, and transportation networks, road, rail, and air, being shut down entirely for extended periods. The rainfall and storm surge components of Atlantic System 2 compound the wind threat significantly. Frontal rainfall of 70 to 100 millimeters over 24 to 36 hours is expected across much of western France, the Low Countries, and the British Isles, arriving on top of saturated ground and onto river catchments that are already running high from Atlantic System 1. Storm surge along the southern North Sea coast, the Netherlands, Belgium, northwestern Germany, is a specific and serious concern. The funnel geometry of the North Sea means that strong westerly and southwesterly winds driving surge into its southeastern end can produce coastal water levels well above predicted tides. And the wind direction during the peak of Atlantic System 2 is going to be almost perfectly aligned to maximize that surge effect. Dutch and German coastal flood authorities have been issuing preparedness advisories. If you are in a low-lying coastal area of the southern North Sea region, please take those advisories seriously. Across Asia, this same planetary scale atmospheric pattern is expressing itself in a third distinct but connected storm train targeting Japan, the Korean Peninsula, and coastal China. A series of rapidly deepening extratropical cyclones tracking across the Sea of Japan and the Yellow Sea is going to deliver an almost unprecedented sequence of heavy precipitation and high wind events to these regions over the next 7 to 10 days. The first system in the Japanese corridor has already produced record or near record snowfall accumulations across western Honshu and Hokkaido, with some mountain locations receiving over 2 meters of snow in a 72-hour period. The second system in this sequence is now organizing east of the Philippines and is expected to track northeastward, bringing heavy rainfall of 100 to 200 millimeters to portions of southern Japan and the Korean Peninsula over a 48 to 72-hour period before it too transitions to an extratropical cyclone and delivers damaging winds across northern Japan and the far eastern Russian coast. I want to step back for a moment from the specific regional details and talk about what makes a global storm train event like this one so particularly dangerous from an emergency management and human impact standpoint, because it is something that individual storm forecasts do not always capture clearly. The danger of a storm train is not just the cumulative precipitation or the repeated wind damage. The danger is the cumulative exhaustion, physical, financial, and institutional, that these events produce in the communities they repeatedly target. When a single major storm hits a community, the emergency management systems activate, the resources deploy, the recovery begins. It is hard, but the systems are designed for it. When a second major storm hits the same community 3 days after the first, while the roads are still closed and the power crews are still in the field, and the shelters are still full of people displaced from the first event, the system starts to strain. When a third storm arrives, before the second has finished, the system can break, resources run out, personnel become exhausted, communities become isolated. And that is the scenario that the atmospheric pattern currently in place has the real potential to produce across multiple regions simultaneously. I want you to keep that cumulative picture in mind as you make your preparations, because this is not a storm you prepare for and then recover from before thinking about the next one. This is a sequence you need to plan for as a sustained event. This is exactly the moment where I need to talk to you about Max Alert, and I want to explain why this particular event makes it more important than any single storm warning ever could. During an extended storm train event, your ability to receive timely, precise, location-specific warnings is not a convenience. It is the foundational requirement for every other preparation decision you make. Knowing that a tornado-warned supercell is approaching your exact location at 2 in the morning, when you are asleep, when your phone is on Do Not Disturb, when a standard push notification will never reach you, is the difference between waking up in your shelter and not waking up at all. Max Alert solves this problem directly and completely. I call your phone, not a notification, not an alert tone that your phone might suppress. A direct voice call from me. Personally, the moment a tornado warning polygon covers your exact location. During an event like a multi-day storm train that includes both severe convective threats in the southern states and prolonged wind and flood threats along the coasts. Threats that arrive at unpredictable hours across multiple days. Having Max Alert active is the single most important weather preparation step available to you. It is $14.95 for a full calendar year of coverage. The link is in the description of this video. Setup takes less than 2 minutes. Please do it now, before this storm train reaches its peak, because the window to prepare is closing with every hour. The severe weather component of this event across the southern and central United States deserves direct and specific attention as I close this forecast, because while the flooding and wind threats have dominated my discussion of the individual systems, the instability and shear values developing ahead of the third system in the Pacific Train, as it deepens and ejects across the Rockies into the Central Plains, are producing a severe weather environment that I cannot in good conscience minimize. The Cape and wind shear combination forecast for portions of Texas, Oklahoma, and Kansas during the peak afternoon and evening hours in the 36 to 48-hour window is producing indices that rank among the highest observed this early in the season. Supercell thunderstorms developing in this environment are capable of producing significant tornadoes, and the nocturnal component of this threat, the continuation of strong convection through overnight hours when public alertness drops to its lowest level, is exactly what Max Alert was designed to address. Have a shelter plan. Have your alerts active. Do not become complacent because you survived the first storms in this train without incident. I want to close this forecast the way I always try to close when I am describing a situation with genuine historic potential, by grounding every atmospheric detail in the human reality it represents. This storm train is going to test communities across North America, Europe, and Asia over the coming 7 to 10 days. Some of those communities are already being tested right now. The flooding rivers in the Pacific Northwest, the Irish coastlines being lashed by Atlantic System 1, the snow-buried valleys of western Japan. These are not data points on a weather map. These are places where people live, where families are making decisions right now about whether to stay or go, whether to act or wait, whether to take the forecast seriously or dismiss it as another weather warning that will probably amount to less than predicted. I'm telling you, as directly and as plainly as I know how to communicate, that this one will not amount to less than predicted. This storm train is real. Its impacts are going to be historic in multiple regions simultaneously. And the best thing, the only real thing, you can do to protect yourself and the people you care about is to get accurate information early and act on it decisively. Share this forecast right now. Send it to your family across every affected region. Post it in your community groups and neighborhood networks. Text it to the people in your life who do not follow weather closely, but whose homes sit in floodplains or on exposed coastlines or in tornado country. Because the train is already in motion, the track is set, and the only variable left is whether the people in its path are ready when it arrives. Subscribe to this channel immediately and enable all notifications. I will be live and continuously updating coverage throughout every phase of this event, from the Pacific landfall happening right now through the final Atlantic system clearing the Scandinavian coast at the end of the week. I will not leave you without coverage for a single hour of this storm train. Stay safe, stay prepared, and I will see you in the live stream.